My name is David Manolitsas, and I'm a software developer at Marlo. And at Marlo, we specialize in the delivery and support of APIs and microservice architecture. We also provide DevOps services and digital enablement solutions. And for myself, I primarily work on API development, as well as building some utility applications that we use to improve our development pipelines and workflows, and one of which I am here to talk to you all today, which is our new open source project, API registration. So I'd like you all to consider the following. We have our API gateway implemented, all of our scaling, lifecycle management's been completed. We have this powerful tool at our disposal. But how do we utilize all the capabilities that a new API gateway provides? Well, at Marlo, often we see at our clients this sort of conflict or this sort of tug of war, if you will, between development teams looking to improve their delivery cycles and publish their APIs to their gateway, and in platform management teams managing the gateway looking to apply API governance. And it's this sort of conflict that sparked this interest and the topic of API registration. So in today's interconnected digital landscape, API gateways are essential for secure and scalable data exchange. And API registration is the process of making an API available through an API gateway. API registration is about empowering developers to improve the experience of building their APIs and speeding up development times to allow developers to utilize the capabilities that their gateway provides. API registration also serves as a building block for API governance and provides organizations with the tools they need to govern their APIs. API registration also promotes API discoverability through emphasizing the importance of API design and documentation. And these are the core pillars which make up the API registration process, and be good to keep at the forefront as we go through some of the capabilities that the API registration project provides. So typically we see at clients after implementing a gateway, they'll often focus on infrastructure and operational teams to support the new capabilities that their API gateway provides. And this can often feel like one step forwards and two steps back as new problems arise, such as existing API teams need to migrate their APIs to the new gateway, and then new API teams that are formed require a lot of training and documentation, updating standards and workflows to understand the capabilities that their new gateway provides. And API registration aims to create a transition solution to manage the onboarding of an API while providing additional benefits across the business. And this includes things such as an automated API onboarding experience, applying and verifying API standards, and ensuring that deployments are consistent and repeatable, and allows developers to manage their own environment workflows. So let's go a little bit deeper into some of the capabilities the API registration project provides. API registration all starts with an open API specification. Typically, when a new gateway is implemented, it involves training development teams to understand either gateway-specific languages or configuration, and API registration aims to address these issues by removing a lot of that overhead, and we achieve this by utilizing the open API specification. We can learn all the information we really need to know about an API from its spec, such as things such as like the server URL, paths, request type, responses, and so on. We're then able to take this information and generate gateway-specific configuration that we can then use to onboard an API to its target gateway. We then provide the ability for developers to enhance their API by providing a small uplift to the API spec in the form of open API extensions. And these provide developers the ability to enable specific gateway features in the form of these extensions. And this allows developers to be really flexible in terms of how they want to customize and build their applications before publishing it to their gateway. So let's take a look at how a developer would do this. So these extensions define how developers can apply these gateway features. And we achieve this by using gateway agnostic configuration. It's because the API registration project has no preference as to which gateway it's targeting, and we achieve this by mapping generic configuration to gateway-specific values, which would then be used to create our gateway configuration files, which would then deploy to our target gateway. So let's take a look at a small example here. This is how a developer would enable specific gateway features right in the API spec in the form of these open API extensions. In this example, we have rate limiting and request size limiting enabled. Under rate limiting, we have a configuration of 3 requests per second, 40 requests per minute, and 120 requests per hour. And then we have a request size limit of 128 megabytes as the allowed payload size. And this is how a developer would enable their gateway features within the API spec in the form of these open API extensions. So now we have a little bit of context about how developers would enable these gateway features as part of the API registration project. We can go a little bit deeper into some of the more capabilities that the API project provides. So API registration runs as a pipeline added to an existing API development workflow. And this is made up of various modules with distinct roles and responsibilities. The first of which is our lint module. And our lint module, as the name suggests, is responsible for linting the API spec, ensuring that it's correctly formatted and that the data that's been provided is of the correct type. The next module that runs is our validate module. And our validate module is responsible for doing another validation over the API spec. But what differentiates it from the lint module is that it's focused on those gateway agnostic configurations that developers would provide. And we use validation rules to ensure that the values that are provided adhere to the API development standards set in place by an organization. And we'll go into deeper into how that all sort of is configured and comes together. The next module is our process module. This is responsible for mapping our generic configuration to our gateway specific values. And then lastly, we have our apply module. And the apply module is responsible for generating our gateway configuration files, which will be our final deployable artifacts, which we'll then use to deploy to our target gateway. Another thing to note about the modules is that we can run these in various configurations to suit different use cases. So, for example, we may only want to run the lint and validate module on, say, a developer's feature branches, or some combination of these modules, and that configuration is entirely possible as well. So as I mentioned, the API registration pipeline gets added onto an existing workflow. In this example, this is running on our GitLab, and we have an API registration targeting a Kong gateway instance of version 3.2. And we can see after the API development pipeline is completed, we run our lint validate module, followed by the process module, which would then apply our Kong templates, which would then be used to deploy our gateway configuration or API configuration to its target gateway. So let's go a little bit deeper into these modules and break them down one by one about sort of capabilities that they provide, and keeping those core pillars that we mentioned at the top of the talk at the forefront as we go through these modules. So the lint module is responsible for handling the linting of our API spec. And this uses a fully configurable schema, which can be customized depending on different use cases and business requirements. Another thing to note about the lint module is that it can be run in parallel with other pre-existing linting tools, which are used all around the world. The next module is the validate module. As I mentioned earlier, this is responsible for validating the configuration defined by developers as part of their open API extensions, which are sort of our gateway features, we can think of them as. And we achieve this by using validation rules we call guardrails. And the guardrails define the boundaries for how a developer can implement the specific gateway features within their API spec. So let's take a look at these guardrails. The guardrails define clear standards for API development and exist in a centralized repository for API standards and policies. And they define the clear API standards that a developer can be used as part of the API spec. So let's take a look at the previous example where we had the rate limiting and request size limiting plugins enabled. So these two gateway features have been written by the developer. They want to be deployed and applied to their gateway, the API that's deployed to their gateway. So I'd like to highlight the second config under rate limiting and consider the point of view from an organizational standpoint where you want to clearly define how rate limiting can be implemented by developers. And this is where the guardrails fit into this picture. They define clearly how rate limiting can be implemented. So let's take a look at these guardrails. They're written in configuration files that exist in a centralized repository. So we're focused on the rate limiting and specifically the second config. In this guardrail, we can see a clear range being defined by an organization with a minimum of 5 requests per second to 10 requests per second. In this example, where the developer has applied a configuration of 3 requests per second, this breaks the guardrail that's been defined by their organization. The API registration pipeline will flag this as an error, highlighting where in the API spec the guardrail has been broken, and providing valuable feedback to a developer that their second config is below the minimum value of 5. And this allows organizations to easily govern how gateway features can be implemented by their development teams. So as I mentioned a little bit earlier, the guardrails exist in a centralized repository for API standards. And we have a hierarchy structure where we can have lower precedence layers overridden by higher precedence layers. And this is to cater to the different layers of governing that may be required for various use cases. So for example, different environments or different teams may need varying levels of API governing. As an example, we have under the teams, we have a loans team and an accounts team. For example, the loans team might need a higher rate limit on their gateway feature compared to the accounts team. And this flexibility is provided as part of this configuration. So API governance is one of the core pillars of the API registration project. And the guardrails and the validate module aim to increase productivity by improving the developer experience of enabling these specific gateway features and reduce risk across the entire API portfolio. So let's take a look at the next module. The process module is, again, one of our larger modules, and this is responsible for taking our gateway agnostic configuration and transposing it into our gateway dependent configuration. In the process module, we also introduced the concept we call defaults, and the defaults are a set of open API extensions which are injected into the API spec before the processing begins. And this allows organizations to automatically apply gateway features to their services. And this all takes place as part of the process module. So we can take a look at these defaults as well. Similarly to the guardrails, they exist in a centralized repository for API standards and promote API standards and policies. They define and apply specific gateway features automatically to a developer's API. So let's have a look at this, how these would be written. A small example again, but here we have the rate limiting applied at the API tag. And what this means is that the rate limiting would be applied across the entire API service. We also have the request size limiting applied at the post tag. And what this means is that the request size limit will be applied at all API endpoints with a HTTP method type of posts. And this provides the flexibility for organizations to set where they want these gateway features to be applied to the developers' APIs. So just like the guardrails, the defaults are in that centralized repository, follow the same hierarchy structure where we can override lower precedence layers with higher precedence layers. And this configuration is fully customizable and extendable, where we can add further layers as required. Another capability that the defaults provide is that of API authentication and API security. Now, API authentication is a huge topic in and of itself, and can be a talk on its own. But the point I want to get across and what API registration provides is that it allows organizations to automatically apply API authentication across their entire API portfolio. And this is achieved by extending the defaults configuration. This supports a lot of industry standards such as OIDC and OAuth 2, as well as JOT tokens, WebAuth, and so on. And this can be applied at the various layers the same way the guardrails and defaults are applied, and removes a lot of the developer overhead for implementing API authentication and security on their services. And this helps to really streamline that developer experience of building their APIs. So lastly, we have the apply module. And this is responsible for generating our gateway-specific files. It takes the configuration from the apply module and applies it to a template file, which will then generate our final deployable artifacts, which we can then use to publish our API to its target gateway. So that's an overview of the API registration project. As a quick recap, the OpenAPI spec is taken as an input. It's then linted and validated to ensure that it's correctly formatted and that any OpenAPI extensions that have been provided by developers are not breaking any of the guardrails set in place by their organization. The process module will then apply any defaults set by the organization, and then before it's then applied to a template file, and then finally published to a target gateway. The next thing to note as well is that since we have the OpenAPI spec available, we're able to take that API spec and, as part of the publish stage, deploy it to an API developer portal, whether that be an internal or external facing developer portal. And this helps to really drive home that idea of promoting API discoverability and API documentation. So I'd like to now just touch on the topic of API first, as it follows a lot of the common goals and ideas that the API registration project provides. An API first approach involves developing APIs that are consistent and reusable. And API registration places an importance on establishing a contract early in the development lifecycle for how an API should behave, and emphasizes the value of API design and documentation, using an API description language such as OpenAPI. And this approach establishes a contract between services really early in the development lifecycle. And this allows API development teams to work in parallel and build their applications in parallel because it's been established really early on about how an API will behave. And this positions APIs as the building block for an organization's software and data exchange. And API registration enables an organization to build an API portfolio with an API first approach. So API registration, it establishes consistent API development standards and reduces friction within a development teams and helps to accelerate delivery cycles. Today, more and more teams are designing and building applications as a collection of internal and external services. And the process of applying and establishing API governance can often be met with uncertainty and doubt. And API registration aims to address these issues through the use of guardrails and defaults. It allows organizations to easily govern their APIs and apply API governance and define how they want to govern their APIs for their specific needs. So at Marlo, we believe API registration lays the foundation for organizations and the developers to unlock the power of their API gateway. As I mentioned at the top of the talk, the API registration is a new open source project featured on our Marlo public GitLab repository. So there's a QR code there for people to scan for those who are interested. And hopefully I've sparked some interest for people to come and check out the repository and can come and contribute to this space and see where we can take it. So thank you very much for your time. I hope you've enjoyed the presentation.